So welcome to Monitoring 101. It's about a 12-hour course. According to the schedule, we get out around 11:45 p.m. tonight. We'll have some bathroom breaks and stuff. Things happen. Anyways, so my name's Ilan Rabinovich. You may have seen me here probably almost 10 years ago speaking about some things at LinuxFest Northwest. At the time, I was working on a voter information project called GeekPack. I don't know if that session was recorded, but it was a lot of fun. So, but my background, you probably, if you've heard of me, it's probably around things like Scale and Texas LinuxFest and some of the DevOps days. My hobby tends to be more work, which is running open source events. My role at Datadog is I lead our technical community and evangelism team. So I get to work with folks like you that are hopefully monitoring your systems and learn about your stories, as well as work with our open source community around some of our open source components, making that a better experience. Spent the last 10, 15 years basically working on large-scale web operations, so things like sites like Edmunds.com, where you probably get in your car pricing quotes, or Uyala, if you ever watched video on like ESPN or some big broadcasters. We used to power all of that. So I got to try to build lots of my own monitoring systems around things like open source tools like Nagios and what have you. Sometimes succeed, sometimes fail spectacularly, and we'll talk about some of those challenges. So I promise I'll keep the Datadog pitch very short. This is not the audience to be selling things at, but I figure I should at least tell you who I am and where I'm coming from, so you can find any biases you might see later in the deck. So I work for Datadog. We're a hosted monitoring solution, so it's a SaaS offering. You put our open source agent on your machines. You send us lots of time series data, metrics, and events. We help you do things like intelligent alerting, insightful dashboarding, things like that. We tend to focus on cloud-type environments, so things like containers, virtualization, lots of microservices, all the buzzwords. We're very buzzword compliant. But we do somewhere around, we're doing nearly 1 trillion data points per day. So imagine what you've got, multiply that out by thousands upon thousands of customers, and we've got to monitor all that for you. So we try to make that easier for you. I'll mention that we're hiring. We've got offices in New York, Boston, and Paris, but we are also very remote friendly. So if you're looking to do something like SRE work or build monitoring systems, drop me a line afterwards. I'm happy to chat. Basically, our goal is to help you monitor everything so that you can make database decisions about your infrastructure rather than opinions. We all know everybody has an opinion. It's hard to argue about your opinion, but if you bring graphs and data, you're going to win your argument. So we like to connect with all of the things. Trying to solve business problems like this. Load balancing problems or what have you. As you can see, the guy on the left seems to be out of the pool, out of rotation for some reason. He's not getting any traffic. But the plan for today is we will kind of do a quick background on what is DevOps and why we're finding ourselves in some of the challenges that we have today around monitoring. We'll then talk about some of the challenges of monitoring dynamic infrastructure and why maybe some of our existing tools don't fit in that mix. Tools and methodologies don't fit in that mix. We'll then go into a little bit of theory, and then talk about what you want to find in a tool that you're looking for. For most of this, I don't talk about any particular tool. You're welcome to find this in any. You can implement a lot of these ideas in any tool you have. So if you came here for like a monitoring, the tutorial around how to set up your Nagios systems, this is probably not the place for you. But if you want some abstract ideas about how to think about your monitoring systems and how to avoid things like pager fatigue, that's where we'll be focusing today. So, brief history of DevOps in our focus area, right? I know everybody has their own definition for this. The one I like to subscribe to came from John Willis and Damon Edwards at DevOps Day LA. About 2010, and they described this DevOps area in sort of 4 categories. The first is culture, automation, metrics, and sharing. Sorry, the first is culture. The rest are automation, metrics, and sharing. We're going to focus on the latter half of this today, but I think it's all relevant and interesting. So what do we mean by culture, right? It doesn't matter what tool you guys buy. It could be the Nagios thing. It could be some commercial thing you pick up off the shelf. You could be automating your life to your heart's content, but if you build it, if your culture does not support what you're trying to do, you're not going to succeed. It doesn't matter how much automation you have or metrics. You're not going to be sharing them with your team. You're not going to be working collaboratively. You guys are going to be working in opposite directions, right? And so I think this quote from Conway says it best. If you have any software that you build is going to reproduce the dysfunctions of your team. So if you're top down, the software is going to have those types of controls in it. If your team has to fill out three pages of paperwork in triplicate in order to get a server somewhere, you're going to build a BMC workflow of some sort that does the exact same thing, and you're going to hate it. It doesn't matter if you call it dev. If the vendor told you this was a DevOps tool, you're still not going to be finding yourself with that level of collaboration you're looking for. And I think this is sort of, you can sort of see this in the real world if we move away from computers for a second, right? How much automation do you see in this barn raising, right? This is technology that it's been around. These methods and technology that they're using to build this building have been around for 200 years, but they're going to finish that, and they're going to finish it quickly, and they're going to succeed at it. They don't fail very often, right? Because no tool brings you that collaboration, right? They have a plan. They know what each person is doing. They specialize quite a bit. DevOps doesn't mean that everybody that your developers now all have to be sysadmins, or that your sysadmins all have to be developers. Specialization is okay, and that it's all about that collaboration and culture across team boundaries, right? Once you have that, go buy yourself a crane. Upgrade from those bash scripts to your chef recipes or your Puppet manifests or your Ansible or SaltStack or whatever it might be. Move to amazing cloud things. You're going to be a lot more productive. But it's going to be because your teams are aligned and you're working towards the same goal. The tools are just going to accelerate that. So that's the automation part. Metrics. So why do we care about monitoring? Well, you wouldn't drive down the street with your visibility obscured, with wipers off, headlights off in the middle of a storm, in the middle of the night, right? You don't want to be running systems in production without monitoring either, right? You want to know where you're going. And those metrics can be things like how many pages are your team getting a week, or how many stories, or how many lines of code are you writing, or whatever it might be. You find the metrics that are important to you and you monitor them, but track them. We're all engineers. We know you can do much better with data than you can do, again, with opinions, as we were saying earlier. And you really don't want to find yourself in situations like this. This is a hilarious guy, Honest Update on Twitter, just sort of cracking jokes at people's status pages. But this top one up here. I mean, how many folks do postmortems in their organizations after they've had an incident? Just raise your hands, right? How many of your postmortems have said, "I don't know what happened, but I promise I'll add monitoring for the next time"? Everybody's afraid to raise their hands, but I know all of you have had this situation, right? It's not good. It's not a good position to be in. So we want to monitor to avoid that. Because we are going to have, no matter how much visibility and how much monitoring we put in there, we're going to have issues. But at least if we have the data, we can make some decisions. Make sure it only happens once rather than twice or 3 times before we actually catch the problem. Right? We want to kind of avoid things splattered across the front of our windshield. And like I said, it can be, metrics don't have to be, this actually doesn't look that great on the screen, but metrics don't have to be all monitoring, all systems related data, right? In this case, what I'm looking at is, a bunch of graphs around what's alerting a team most, right? I think it says something like MySQL alerted somebody 1,650% higher this week than last week. That's a lot of alerts. The point is, though, it doesn't matter. It doesn't matter what those metrics are in your organization. They might be, again, how fast you're delivering an API call, but they also may just be how well you're working as a team. Figure out what those are for you, and work down that. And we'll come back to some ideas on about that theory in a little bit. So sharing. Sharing's really a loop back, sort of a loop back on the culture thing again, but it's sort of important to reiterate. It's good that we all need to learn together from these things. When we catch incidents, let's have those blameless postmortems. Let's get in a room and learn about how we could have done better. Own up to if you screwed up, own up to it. You won't do it next time. Your colleagues are going to respect you for it. Describe the problem that you're working on as the enemy, not each other. So it's not the developer that put a memory leak in the code. It's the overall process that you as a team could have, maybe have implemented. There are overall processes that you as a team could have implemented to catch that at every step of the way. It's not the first guy's fault, or it's not the last guy's fault. Somewhere as a team, you guys get to own that together. And really, I think that's a good story. I like to point to when you're looking at this. Does anybody know what this guy is here on the right?
Mars Climate Observer.
Yes. So what happened with the Mars Climate Observer?
It got lost.
Well, if blown to smithereens is sort of your idea of lost, then great. But yeah, you really want to be using. So when we're talking about all these metrics and we're talking about the sharing, you want to be using common languages and common metrics. Make sure that everybody has the same, is aligned in the same direction. What happened with the Mars Climate Orbiter is you had the folks at Lockheed Martin thought it was a fantastic idea to use the customary system, so they're measuring things in feet per second and pounds, and then you had the folks at NASA who were in the modern era and decided to use the metric system, and it turns out that those numbers are not the same. And if you don't know to translate between them, because the guy just said, "Oh yeah, it's 5 things away," rather than saying they're 5 feet away, you might crash into something like a planet, and it might cost you something like $125 million to fix that problem. So, and many years of lost work. So anyways, that's sort of it. But that's the quick tour of DevOps. I think it's about under 10 minutes of what DevOps is. Today we're going to focus mostly on that metrics and sharing part and how your monitoring fits in. Some sprinkles of automation. I can't give you a culture, but hopefully that's something that you can bring to the table, and then you get to pour the rest of the ingredients in, mix them together, and build yourself an awesome team. So the mantra I want you all to think about is, as we're working on these things, as we're talking through this, is that collecting data is cheap. I know lots of we have this, especially folks that come from a sysadmin background or a storage background. You think to yourself, man, that's a lot of data. We're never looking at that data. Like it only gets read 20% of the time, whatever it might be. Doesn't matter. It's cheaper to collect it now and store it somewhere these days than it is to find it, and then just to try to regenerate it when you don't have it, right? We talked a little earlier about those postmortems where you say, I don't know why it happened, but I'll add some more monitoring to it later. Just instrument everything. If it moves, graph it. If it doesn't move, graph it anyways. You'll have a straight line, and then you'll know when it jumps, right? You'll know when it tries to make a break for make a break for the door, and you'll be able to come back and look at it later. So yeah, again, instrument all the things. This means monitoring your operating systems, your databases, your applications. If you write a custom application, generate a bunch of custom metrics from it. Make sure that you have all of the data, whether or not you think you need it now, because you're going to need it someday, and you're better off having it. But we're in this world of the cloud, right? How many folks are using some sort of cloud provider today? If you're not using a cloud provider, hopefully you're using some automation around spinning up your systems. It's not like a guy running the data center to put drives in the rack every time you need something. Maybe it is. I mean, maybe if you work at Amazon, yes, please do that, but because I need that storage. But I don't care what provider you're using. At the end of the day, we talked about automation a little bit earlier. The exciting thing about today is we get to scale with code rather than people. How many? Like I'm no longer in a position where I have to say, let's wait 6 weeks for more servers to show up from Dell or HP or whomever. My provider handles that for me. Again, I don't care how you define cloud. I define cloud as I get to use somebody else's equipment, and my credit card is my scaling bottleneck, not the number of systems I can shove into racks. And it's amazing. We have all these cool things around there, right? We have managed databases and auto-scaling, and I realize I'm mixing Google and Amazon logos for services, and you don't have to use these, but it's an example of what's going on, right? All of these things are, this is amazing. This idea that you can just scale up with a credit card and scale back down when you're done. This is sort of what I dreamed about 15 years ago when I was starting in this space. Of like I tried to build these things and probably failed at it. And we've also had things like this Docker stuff. It's all folks are using containers here. Yeah, cool. So it's coming around and changing a lot of how we interact with our systems as well. We did a study back in October about Docker usage. There's a link there. You'll have the slides later, but we saw something like 5x increase in Docker usage over the last 12 months. It went from 0% of the things we were monitoring to 6% of the things we were monitoring. And remember, I was talking about trillions of metrics earlier? You can kind of put that into context. I don't know when the last time we saw something pick up that fast is, but these things are changing all around us, right? And so as we're trying to monitor our things, and I said instrument all of the things, but you have to know where the things are in order to monitor them, right? And so, again, another honest status update guy. If you don't, these things are moving out or underneath your feet all of the time. If you're in the cloud, hopefully you're using things like auto-scaling groups or whatever the equivalent is in your cloud provider. And so these things are going to be bouncing around you. We'll talk a little bit more of that in a second. So our apps have kind of taken this sort of a shift, right? They used to be you drop a server on the rack, you toss your software on it, you're done. And then we thought, let's do a smaller deployment units. We'll split up those hardware into VMs, and we'll have a couple different VMs on that box, but they'll be mostly the same, mostly one app. It'll be a little easier to manage. We can spin them up and down faster. That's what I'd say is probably like the last 5 years we've had in the cloud. And then like the last year or two has been this time of the containers, all the way on the right. And what we're doing is basically all we're deploying is our app. Like it's like back in the day when they promised us we'd be able to just drop our Java app on top of our hypervisor. We're almost at that like world of unikernels. Right now we're in this container space, and we get to deploy just that one bit that matters to us, and it lets us move a lot faster. But again, things are also changing out from underneath us. So the goals here are to do things like as whether we're using cloud providers or containers or what have you. I mean, there is a purpose for it. It's not just because we read about it on Hacker News or TechCrunch today. I mean, we're trying to take sort of things like this, where we've strapped all kinds of things to our roof, we're putting them together, trying to make things fit and use all of our systems to their capacity. We're trying to turn into something like this, something that's more standardized, faster deployments, simpler to use. That crane we were looking at earlier can pick up one of these and shove it on a truck, on a boat, what have you. Again, it lets you go across cloud providers, across infrastructure providers, et cetera, and moving a lot faster. But this adds operational complexity. So how do we define that? Well, first is the number of things we have to measure, and the second is the velocity of the change around those things. So what do we mean by that? Well, so again, I've been operating in Amazon for the last 7+ years, maybe more. So I'm going to stick with some examples from that world, but you can apply this to your own infrastructure. So how much are we measuring? Well, CloudWatch, which is the underlying monitoring system that Amazon provides, is about 10 metrics. Most monitoring systems we see people interact with are picking up about 100 metrics from the individual host, and maybe about 50 metrics per application. I realize this may not apply to yours. This is just like a general average of what I see people doing. It changes every time I take the number. But this is the last time I checked, give or take. Now we talked about containers a little ago. In our study, we found most people are running about 4 Docker containers per host. That's increasing over time, but you can sort of do the math. And say, let's say you've got about 150 times the number of containers you're looking at. So you start to do this math, and let's say you had 100 instances in your environment, again, VMs of some sort. They're now 400 containers. At 640 metrics per host, it should be per container, 640 metrics per host, 100 hosts, that's 64,000 things you're measuring, and hopefully you're measuring them at second granularity or something near that, not like once an hour, because these things are changing faster than you are probably measuring them. So let's get them down. But that's a lot to look at. It's kind of a bit of metrics overload. And we talked about earlier how we want to measure all the things, whether or not they change. So you got to store that somewhere. You got to think about how to process that, but we'll come back to that in a second. So we talked about the number of things to measure. That's clearly changing. What about the velocity of change? What we're finding is that VMs these days stay around for about 12 days. So VMs stay around for about 12 days. Containers, about a fourth that time, so at 3 days. And it's getting, all of these numbers they're on a downward trend. They're not on an upward trend. So this idea that you could shove something in a Nagios config or what have you, I love Nagios. I don't mean to beat up on it. It's just a good example because I know it very well. But the idea that you can shove something in monitoring and just worry about it when it alerts you is kind of changing, because the thing is it's going to alert you all the time. It's because we're talking about things that are going from things that we thought about in hours before or days are now in minutes, minutes or seconds. So we're cutting down our times pretty quickly. Slides will be online later. You can save your camera memory. So we talked about number of things that are changing. We talked about the velocity of that change. And so how do we avoid kind of this reaction when we start to look at all those numbers? It's a little overwhelming, right? Sorry, I don't mean to. Hopefully, there we go. Wasn't trying to hypnotize you there. You will all rate this talk amazingly. So anyways, this is so we need some monitoring systems and monitoring practices for how we're going to think about these things, for how we're going to think about about monitoring and metrics, right? We can't be using relics from the 1960s, or in the case of a lot of our open source monitoring tools from the early 1990s. We want to be in a situation where we can measure all that data at the rate it's changing, and still receive meaningful automated alerts. Quickly investigate things, get down to the bottom of it. No, you're not monitoring it for the sake of monitoring it. You're monitoring it because you want to be able to solve the problem before your customers noticed it, or get back online before they get too angry with you. So how do we find meaning in all that noise? So we have what we call Monitoring 101, which is a series of best practices around how to interact with your data. This comes from these are not a lot of these ideas aren't entirely fresh to Datadog. Google has an amazing there's an amazing Google doc out there that SRE at Google wrote about their monitoring strategies. They talk about it a little bit in the SRE book from O'Reilly that just came out about 2 weeks ago. Baron Schwartz from Vivid Cortex has some amazing writings about what he calls the use method. This is our sort of spin on all that. Some of it's from our customers, some of it's from learnings from the industry. But the first thing that we would say you should do is start. And this projector's really not playing with my colors. But anyways, the first thing I would say to do is figure out how to categorize your metrics so you can determine what's important. And we break them into three major categories. In our world, we have what we call work metrics. resource metrics, and events, and we'll kind of dive into what those are in a little bit. But if you think about your app, if you think about your application or your service as a factory, right? This is like rather than API calls. Let's say you're producing cars, right? Let's talk about what these categories would be. That's abstract enough that I'm not arguing with you about QPS for your particular app and whether that's a work metric or a resource metric. It gives you a place to start. So again, we're in a car factory. I mean, I think this was a textile factory of some sort, not a car factory, but we'll keep going. So work metrics. So work metrics are the thing that you're actually producing for your customers. If you're a web service, it's going to be API calls of some sort, but in the case of this factory we're talking about, it's throughput would be things like how many cars are we pumping off the assembly line every week or every day. Success is going to be things like how many of those cars show up with all of the hubcaps on and all the wheels on them and ready to drive and sell, and how many of the errors are going to be things like how many lemons are we producing. So how many of these things have to come back to us from the dealers? How many of things do we look at and we're like, oh man, I forgot to put that extra tire on there. It's not really going to roll off the assembly line. It's going to make some noise. And performance being things like how quickly can we not the throughput, but rather the speed of how we can generate one of these things. Resource metrics, on the other hand, are all the things that go into building these cars. So you're talking about the tires, the windshields, all of the pieces. Utilization is how many of the pieces that we have, and whether it be the things in our plant that are building these cars, or the materials that we have. How many of those do we have sitting? Do we have available to us to use if we want to pump out more? If we want to turn up that knob and push out more of those cars. Maybe some guy I share a name with promised a car that doesn't exist yet, and you now have to make 300,000 of them or something. And then again, availability of those resources, availability of the things that you depend on underneath you. The last category is events. Events are these things that provide context. They're not metrics in their own right. You're not measuring them to see how many events are happening, but rather, you might be, but it's more things like, changes in the process for how you build that car that might have gotten you, now you're getting more throughput without using more resources. It could be, in your world, it's probably going to be things like code changes. Maybe again, it's that thing I was talking about. We were talking about earlier how the CEO I share a name with started selling a bunch of cars that don't exist yet. Maybe you got to turn up the manufacturing process on that really quick. These are events. You're going to put these over use these on your graphs to understand why metrics have moved one way or another, and go from there. Like Super Bowl ads, business changes, anything that you have done to your environment or has been done to your environment by somebody else. So to put this in the context of a web app, let's talk about Nginx, fairly popular web server, but this applies to really any web server you use. Again, your throughput is going to be your work metrics. It's probably going to be requests per second. When things like the time it takes you to get the response times and latency to your customer. Error rates and success rates are going to be things like your 4xx's and 5xx's versus your 2x, 200 response codes. And the resources are going to be all the things that went into that: your disk, your memory, your CPU, probably a bunch of things from an underlying web service and your weird, crazy end-tier architecture with lots of lines where you don't know what you built. But that's, those are going to be the resource metrics that you're working with. And then the events are going to be things like configuration changes, code deployments, service upgrades. Did you decide to go, Ubuntu 16.04 is out? Did you upgrade to that on the first day? Like what changes happened in your environment that caused your graphs to go one way or another? And you can kind of see. This is really not going to work on this screen, but you can see in the slide later. There are some pink bars here that highlight over when the changes and the deployments were, and that correspond with the spikes in the graph. I can show this to you later. But the idea is you want to bring these metrics, like as you're drawing these, as you're working with your graphs, make sure that you're overlaying the events that you interact with on top of them, so that you can see why things dove one way or another. Anyways, sorry. So on these things, what are we going to page on, right? That's really the question. Everybody I talked to about monitoring, everybody that I talked about monitoring that says they hate monitoring, it's not because they really hate the metrics. It's because their pager's been going off. And so one of the things I used to do when I was when I was on the tooling side of this rather than on the community management and evangelist side of this was sit down with engineering with an engineering team that might have an on call every 2 weeks. I'd pick the team that had the most alerts and sit down with them and try to apply similar ideas and figure out you got 10,000 alerts last week. that's more alerts than there are, seconds in that period of, like, waking seconds of the day in that period of time. When did you sleep? Or did you just turn that pager off, right? Things like that. So you want to think about, alerts. Alerts don't necessarily mean pages, is the real thing that I'm trying to get across here. Alerts really are records or notifications in a period of time that something changed one way or another. You want to use them, again, for anything that's low severity, things that aren't worth waking people up for, that's fine. Alert all the time, just don't even have it go to email. Just have it in your monitoring system in your time series data store so that you can see when it would have fired, when you come back 2 weeks later trying to figure out why your service has been behaving differently or what have you. Or the next level up would be notifications. Send an email. Somebody can get to it tomorrow during business hours. You don't have to wake up in the middle of the night. If they have to wake up in the middle of the night, if you're not returning those API calls anymore, then page somebody. But really think about your staff are not resources. Don't use them as sort of meat shields in your monitoring systems. Just put together some effective alerting. So again, some examples of what would I say to alert on? So we talk about alerting on those work metrics. Those are the things that you really care about. They're the symptoms that your customers will experience. So if your SLA is 5-second response times on your API, when it starts to deviate from the 1 second it's been having all year, alert on that. Again, things that are changes in throughput, changes in those success and error rates that we talked about before, changes in performance, maybe the latency is higher, things we were talking about. Really don't try to page on these resource metrics or the events. You're going to use them when you come back to try to do some troubleshooting and figure out what's going on. Now there's some exceptions to this, right? If you've got like a database and your disk is full, or it's filling up steadily, a couple of gigs a day, and you know that in like a couple hours you're going to be out of disk, alert on that. Please don't have the outage. Like there's some exceptions. You need to figure this out in your own environment. What makes sense for you, But in general, try to focus on those on those work metrics. They are the symptoms, right? It's not really helpful to anybody to know that CPU is high or what your load average is if you don't know that your services are actually providing what your customer was looking for, right? This is Adrian Cole, who from the JClouds project and a couple other really cool open source automation and monitoring projects. You definitely should follow him if you get a chance. But so what we're going to start to do in our workflow is we're going to you might get an alert about a work metric, whether that's a page or an email or something else. We're going to investigate why that thing happened. So why did we start returning API calls as fast as we were before? We'll look at our resources and the events. Maybe we did a deployment that day. Maybe something happened in our cloud provider. They had an incident of some sort. And if we can't find it in our particular part of the world, start looking at other levels in the stack, right? And I think the key point here is that regardless of where you are in your infrastructure, you have a work metric. Even if you're this guy all the way at the bottom, you're like you're the DBA that runs some MySQL server all the way at the bottom of the stack. You are no less important than anybody else in the organization. Your work impacts the top level customer experience as well. And so you have a work metric. Figure out what that is. Maybe in your case, maybe it's how fast you return those SQL queries, and graph that, alert on that, make that your baby. But as we dive down the stack, trying to figure out why we're having an issue, this is where we're gonna, this is sort of the path we're gonna follow. Peel back the layers of that onion. So where does our current monitoring fit into this space, right? We've talked about the rate of change. We've talked about the types of alerts that we want. We want to focus on these work metrics, not the resource metrics. And it's some text off the screen. Sorry about that. But anyways, so a lot of the methods we've been using sort of don't really stand up to this new time that we're talking about. And I don't even mean that. I mean, to some extent, I mean some of the tools, but really, I mean a lot of it's just our methodology and how we think about it, right? These are relics from the past, not where we want to spend our time. Not the newest and shiniest things, modern tools we come up today, right? Nagios came out on March 14th, 1999. And for the most part, it's a very similar architecture to what it was back then in a world that wasn't changing at all. Cacti, 2001. So these are tools that are now 15, 16 plus years old. They're fantastic tools. I've spent many a night automating things around them. But they didn't really take our current world view into account when they were being built. And so, we're doing a lot of sort of square peg, round hole type work with a lot of our monitoring tools. We have way too many tools out there. You probably have a tool for monitoring your network. You probably have a tool for trending. You probably have a tool for alerting. You probably have a point solution. Maybe you're running Hadoop, and so you have something from Cloudera or Cloudera or Hortonworks or some vendor for monitoring just the Hadoop piece. You've got Cassandra, and so you probably grabbed Ops Center from Cassandra, and you grabbed something else from somebody else. And now you have so many dashboards that you kind of feel like this guy trying to figure out which thing you should respond to, where you should look, and what you should do, right? It doesn't, sorry, I'm going to stop this because I don't want to give anybody a seizure. But the point is, we need to, yes, monitor all the things, but we need to do it intelligently. We want to bring all the things into in sort of a single view. And again, I'm using the Amazon logos here, but this applies to anything. You want to be alerting and trending off of the same data in the same data stores. Otherwise, you're going to be getting pages for things. You come back, look at the graph, and the graph looks nothing alike because it's it's averaging on different periods of time or looking from a different data source. Really, just find a way to bring that all into one place. Datadog does a great job of that, but there's lots of other monitoring tools that will let you do this as well. I'm happy to chat with you afterwards about how we can solve the problem for you, but we'll talk more about that later. Stop with the cryptic alerts. Telling somebody that a DB server 1 is down at some time today, or giving it some Greek name. Nobody knows what that means at 3 in the morning. Your brain has already swapped out all of the information about work to disk. You're going to spend about 10 minutes just trying to load that back up as the disk, as the spindles spin, do their thing, and you'll be fixing things 5 minutes into the incident rather than 5 minutes before it impacted your customers, right? What I don't know what this means. So here's a type of this is sort of the alerting template that we would use for something at Datadog, and what we would encourage our customers to do. Put an actual runbook in your alerts, or at least a link to the runbook. If your monitoring system supports enough text to do the full runbook, do that. Don't have when you wake them up, give everybody the context they need right now. It should be in plain English, specific about the problem is, how is it impacting the customers? Because I know a lot of people's first reaction is they get the page I don't know if that's important. I'll wait if it pages again, and they hit the snooze button, they go back to sleep, right? Or if you're, even more importantly, let's say you have a knock, right? And you've built the most amazing app ever. So it never goes down. But then it does go down one day. The knock could call you, or they could have a runbook to solve the problem, explaining to them what to do. And so just put this all in there. So things like how it impacts the customer again, what you should look at, what the likely problems are, links directly how to fix it. So in this example, I've got a link to a Jenkins job directly saying, that's not an actual real URL. I don't know who owns Jenkins.com, but the point is, you can have a job maybe that spins up more hosts or shuts down hosts or redeploys your code, whatever it might be. Have all of that stuff ready so that you're not off to get coffee, rub the sleep out of your eyes, and then back at the computer. Every alert really has to be actionable. I can't stress this enough. If you're alerting on things, every page has to be actionable if you're going to wake somebody up with it. If you're alerting on things, you don't want people to get to the point where they ignore that. Remember, I was talking about that team earlier that was getting 10,000 alerts a week. You're not responding to that kind of stuff. You want to make sure that you're only alerting and paging on the things that your team actually has to interact with. So again, why is it important? What do I do about it? And who do I call next if I get stuck? Next, averages or lies. We talked about this idea that things are changing all the time, right? If you buy a Super Bowl ad and you take an average over the start of that day and across that 24-hour period, and you look at your traffic, you're not buying enough servers. I guarantee it. You're provisioning for that average. And even in the world of the cloud, you have to these things don't happen instantly. You have to think about them, and so you can't provision for your average traffic. Keep the real data. This RRD thing, it was a great trick for saving disk space. I'm not saying you shouldn't do some roll-ups of your data, but looking at 5-minute averages now and then 10-minute averages in a couple hours and then 1-hour averages in a couple days, and how are you going to compare your year-over-year traffic? How do you know what your Black Friday looks like from one year to the next? You don't. So keep all of that data at full granularity, at least for a year. Try to do some seasonality on it. Figure out especially if you're in a space that has seasonality, like I said, Black Friday or Super Bowl ads or big conferences. You come to LinuxFest Northwest, you have a booth, you show off your stuff, now everybody's signing up. Can you hold up with it? You need to know what that traffic looks like. Find tools that let you build dynamic configurations, right? We talked about how all this stuff is changing all the time. I don't care how much Chef or Puppet you wrap around that static config file. Again, I'm still poking a little bit of fun at Nagios, and it's just because, again, it's the tool I know, one of the tools I know best. But this is a Nagios config. Have it pointing at a bunch of servers that are being auto-scaled up and down by Amazon, or remove containers that are being moved around by something like Kubernetes. That page is just going to be going off all the time. You can't converge as fast as the tooling that we have is changing the landscape underneath us. And then we want to start thinking about things in a service-centric way. And what do I mean by that, right? A lot of the tools that we've built so far, they tell you, that we've been using over the years, and the methodologies for monitoring will say, like, tell me that port 80 is up on a host. Tell me that disk is available on this host. Tell me that it's responding. And we're looking at this as all individual hosts. How many of your customers care about that one server behind a load balancer somewhere? How many of them care when they can't access the actual service? A lot. But you can't figure that out in an inverse. And so this picture that we're looking at here is sort of a bit of an analogy. This is the Ptolemaic model of the solar system. This is the Earth at the center. This is all the other planets and the sun going around it. Look at all this crazy math, all these weird machinations somebody had to do as they were drawing this out to figure out where the positions of the things in the solar system. You can't figure it out going backwards. You have to come in, service in, down to the host, not host out, up to the service. And so this is sort of this is a much simpler model, right? This is what we believe today, and I realize there are people that say it's not 100% accurate either, but it's a much simpler way to think about it, and it's much closer to reality. With the sun being the service at the center, and all of us revolving around it. The other planets probably being other microservices you depend on. I don't know. Tags. Tagging is really important as you're looking at your metrics. You need a way to filter through all of that. And so this is an example. Again, this is the AWS console. Every infrastructure tool today offers some way of tagging and labeling your metrics. If you're in Docker, you've got labels on your containers. If you're in AWS or GCE or any of the other cloud providers, they all offer some way of putting tags on your hosts. And what this does is lets you slice. This is going to let you start to slice and dice that data. Come up with questions that ring true regardless of the scale of your infrastructure on that day. And we'll go into some examples here in a second. But if you're looking at something like this, the metric would be things like, this is network traffic on the left, the value here, in the middle, the time, and the tag is the tag explains where. Where did this happen? Did it come from? Which app did it come from? Which host did it come from? Which group of hosts did it come from? Tags can be things like what data center are you in? What availability zone are you in? Again, in Amazon, what failure domain are you in your own data center? When, which power supplies are you on? These are all things that let you slice and dice your data. So you can kind of think about it like this. And again, apologies for the colors here, but if we think about our tags as sort of a way to do that slicing and dicing, this, here what we've done is we've grabbed all of this purple areas. We've said, show me all of the things that are running on T2 smalls in Amazon, and graph a given metric across it, right? And we can add metrics for things like our roles, bring in things like whatever, all the information that you know about your environment, put that into your monitoring system, so you can ask better questions. So stop asking, is port 80 up? Stop asking, is this monitoring, is this, there's enough memory on this individual host? Ask questions about your business that scale as a whole. So all the things that I've underlined here in bold are tags. So, right, show me all the containers running, my web app in region US West 2 across all the availability zones that have more than 1.5 times the average memory on this instance type. These are the types of questions you want to be able to ask your monitoring system. Don't ask, is the port up? Ask on a specific host. This question is going to be true regardless of if I have 10 hosts today or 100 hosts or 1,000 hosts. Similar things like this is more of a work metric than a resource metric that we were talking about before. But how many of my web requests are taking more than half a second to process and respond? Right, that's a business question. You're going to get that from all probably the Nginx response time metrics that we picked up or that we were talking about earlier. And you could look at that on every individual host and try to figure that out, or you can just look at it from the service level, and you'll have what you actually care about. And then finally, find tools. There we go. Find tools that let you send custom metrics out from your application, let you instrument your that let you instrument your environment with what you know about your applications. You know your custom applications best. I know some of us get to run things that are entirely off the shelf. It's maybe it's a little simpler, but if you're running a shopping cart or you're running a web app or you built APIs or one of these other things, or any of these other things, you know what transactions are most important to you. I can't tell you which API makes you money. I can't tell you what API impacts your customers most. You know what your SLAs are. Instrument your applications with those. I highly recommend looking at things like StatsD. Again, I mentioned Datadog, but there's lots of other tools out there as well. Find things that let you emit in a way that is asynchronous, so that your application is emitting those metrics as you're doing the work, rather than something having to connect to them and get that data. Think about it more like passive monitoring than active monitoring. And yeah, I think Yeah, so the reason we're looking at things like asynchronous is if your application has to make a call out to something to let it know, what something's changed, and that thing is not down or not around or is slow to respond, you don't want to impact your customers. But yeah, anyways, that's sort of the story. Hopefully you can apply these things when you get home and stay out of the doghouse. I'm not allowed to use cat pictures. I've got a whole bunch of resources out there in the slide deck, which I believe the kind of folks at LinuxFest Northwest will post. There's a much longer version of this Monitoring 101 piece with a lot more examples online. There's that's the first 3 links. We talk a little bit about the metrics. And then the last project is a couple years back, there was a group of folks that started a project called Monitoring Sucks because it did, and we didn't know how to fix it. It sort of turned into a world of monitoring love these days, but the GitHub repo is still around and has a lot of great data about tools you can use that will let you implement some of the concepts we talked about here. And yeah, with that, I'm done. If you want to chat afterwards about monitoring or how you're doing something in your environment, or whether it be Datadog or something else, I'm happy to have that conversation. But yeah, thanks, and enjoy the rest of your rainy day here in Bellingham.